Good morning, good people. Well, it is morning for me. For some of you who will watch this video, it is not morning. I'm having to do another video because, as I understand, I did not share my screen. So, for first period, I apologize, but I will have this new video or revised video updated to my Canvas page. Uh, so you should have this document and you can follow along and fill in the blank as necessary. So we are continuing our lesson on proportional relationships, and specifically we'll be looking at tables, and then our main focus is proportional relationships and graphs. All right, so what is a proportion? A proportion is two equal ratios. It can be written in two ways: two equal fractions, or by using, it can be written in two ways. You can write it as two equal fractions or by using a colon. We can use ratios to create proportional ratios or determine if ratios are equal. Proportional relationships with graphs. What is the unit rate of this table? All right, so if you remember, to find the unit rate, you divide y by x. Divide y by x. Y divided by x. Yes, I said it again. It'll be all right. All right. Now, so I would do over here, I would do 9 divided by 1, 18 divided by 2, 27 divided by 3, 36 divided by 4. And when you do that, it equals 9. So the unit rate is excuse me, $9 per hour. Is this table proportional? Well, yes, it is proportional because the unit rate is constant throughout the table. All right. Now, we could also see proportional relationships in graphs. So let's look at this graph, and this graph represents the same information that is in the table. Notice that even though our focus is on graph, notice that there is a table that goes along with it. And the reason being is, before you can graph anything, you have to have that information represented in the table. So the two does go hand in hand. So how do we get these points on a graph? How did we get 0, 0? And how did we get this point right here, and this green point right here, and this green point here? How did we get these? It's the information on the table. So what you need to know is that the data in the table represents what we call ordered pairs, or some people call them coordinates, or as I just mentioned, I said points. So to represent that, you would have, you could write it, and this is the convention for writing an ordered pair. You use parentheses, 0, 0. And the convention is that X, comma, Y. So remember the Y divided by the X, the dependent divided by the independent, that's what that means. And that's your convention for writing ordered pairs. Yes, you put it in parentheses. That's the convention. All right. So then 1, 9, and then 2, 18, and then 3, 27, and then 4, 36. All right. So these are the coordinates. These are the points that are in green, these little dots. These are the points on the coordinate plane. So the point here, 0, 0, this is where it meets. The point here, you go over to 1 up to 9, that's where that meets. Over here, you go over to 2 up to 18, that's where that meets. You go over to 3 up to 27, that's where that meets, that's where you put the dot. You go over to the 4 up to the 36 and put a dot for where they meet. And then you would place a line through it to show that the graph is continuous. And this graph is proportional. How do I know this graph is proportional, Ms. Hervey? How can we determine if a graph is proportional? A graph is proportional because it is a straight line through the origin. And here are the two main rules, which is basically what I just said. For any graph, is proportional if the line passes through the origin. That's at 0, 0. The line is straight and increases proportionally. That's how it is. So when we say straight line, straight line has to increase proportionally. What do we mean by proportionally? In this case, as the hours are increasing, so is the money increasing. And this shows that it's increasing proportionally. So that straight line can't be a horizontal line. Okay, that straight line can't be a vertical line. It has to increase proportional. As one is going up, the other one has to be going up. Okay. And so this is what you're looking for when you're determining whether or not a graph is proportional. All right, now let's look at these graphs A, B, and C to determine whether or not they increase proportionally or they are proportional. So look at graph A. Is graph A proportional? Well, it has to meet, it has to meet two criteria. It has to go through the origin and it has to increase proportionally. Okay, so does it go through the origin? No. So because it does not, that's an automatic no, it is not a proportional relationship. Let's look at B. Does B increase proportionally? Does B touch the origin? So yes, it does touch the origin. And it is also a straight line through the origin and it's increasing proportionally. So as the donated money is increasing, is going higher, so are the match donations by the benefactor. Let's look at graph C. Is this a proportional relationship? There is a point at the origin, but it is not increasing proportionally, meaning the number of problems solved does not increase with extra credit points, not for each point. At some point, it looks like it is increasing proportionally, but not here. So in this case, we would say No. Okay. Um, let's look at explain your graph selection and why the graphs are proportional. So we will say graph B is proportional because the graph of the line is straight and increases proportional. Notice how so you could say it goes through the origin. Spell the word right. Notice how in graph A it is a straight line, so I don't want you to get lost on this concept. Yeah, the line is straight, but it's not proportionally straight, meaning as one is increasing, the other is increasing as well. So I just wanted to emphasize that point. Now here, watch what I do here because I am going to blot this entire section out. Oh, I think I know what's about to happen. And give me a minute. I'm sorry. I almost forgot what I'm supposed to be doing. There you go. I'm trying to fill this in. There we go. Okay. Look at that. That was magic. So instead of filling in the blanks right there, I'm going to give you my steps to determine whether or not there is to get the unit rate of a table. So the first thing you do is divide y by x. Okay, so you may want to write this down somewhere, like over here on the side, or you could just put it in your notebook. So when I say use your notes or something, you'll have access to this. So the first thing you'll do is divide y by x. And you do this for each value in the table. If you get the same number for each, then the table is proportional. And that's all I really wanted to emphasize here. I didn't want to go through too much or get us confused with too much in the table. So in this table, if I divide y by x, 16 divided by 2, 32 divided by 4, 48 divided by 6, 64 divided by 8. If I do this, I get 8. I get 8 for all of them. I'll just put that over there. I don't know where else to put it. I get 8 for all of them. So I know the table is proportional and I know the unit rate is 8. Okay. How can you find the unit rate of a proportional graph? First, okay, hold on. First, write the points in a table. The points or the coordinates or the ordered pairs. I don't know how you want to say that, but that's what we're doing. Use the same steps as determining the unit rate. All right, now, so for these graphs, hold on. Y'all give me a minute. Bless me, hurt. Hold on. Okay, here we go. All right. So, is this the same information? Oh, all right. So as we look at the graph, I'm having a moment, bear with me. As we look at the graph, okay, your graph does not have points on it, and neither should it mine. Now we're going to put some points on it. The graph is this line, this proportionally shaped line, meaning as the number of weeks is increasing, so is the total savings increasing. As one is going up, the other's going up. So that's what we mean by a proportional relationship. Bear with me again. I got a good phone ringing, and I need to put that on pause. All right. So I'm sorry. I'm embarrassed right now. All right, here we go. Focus, focus. So as we look at this graph of this line, notice where the line intersects at an X and Y axis. Hopefully that makes sense. So notice where when I say intersect, I mean touch. Y'all should know that. So it touches right there. So there is a point, and that's why I had them points on there. So here's a point because it intersects there. Notice right here it's not intersecting anything, it's in the middle of something. Now, as I continue to go up, again, it's not intersecting anywhere here, but right here where the little light gray lines touch and meet, that's where it's intersecting. And hopefully it's intersecting right here at these numbers so we can easily figure out what our numbers are going to be. Again, it's intersecting here. Again, it's intersecting here. Boop. And again, it's intersecting here. Boop. All right. Now, these are the points at which it's intersecting. And now, guess what I can do? Use this information to fill in my chart. I can also use this information to find my unit rate. And that's what question number 3 is asking. What is the unit rate? So now, what I'm going to do over here is write the ordered pairs for each one. So this first one is at 294. How did I get 2? Well, you go over to the 2 and up to the 94. This next one is at 188. 188. And it's right there in some kind of way. That parentheses disappeared on. All right, this next one is at 6,282. And then the next one, I'll put it over here on this side, is at 8,376. Oops. And then this one up here is at 10,470. All right. So these are the ordered pairs. And that's actually what I put in the table, X, Y. The number of weeks, X, total savings, Y. Remember in the ordered pair, remember that the first number in the ordered pair is X and the second number is Y. So you do need to keep that in mind. Now, remember to get the unit rate, all I got to do is divide Y by X, and I can easily fill in number 3. Some of you have probably filled in number 3 already. But I do want to emphasize, indicate that even though I'm just doing this, that 0, 0 is a point, and it is okay to use it as a point, especially when you can't find another one. Use 0, 0. All right. So 0, 0 is a point, and you do need to know that. All right. So let's fill in the table first before we do the unit rate. So the first one is 294. Does it have to be in order? No. It's good to be in order because it's easy to find a pattern. but you don't have to put it in order. It's just nice for it to be in some type of order. All right, so these are our points. Now we got to find a unit rate. What is the unit rate? Miss Herbie, how do we get the unit rate? I don't know. You divide y divided by x. What is y divided by x? So I could pick any one of these. I don't have to do them all. So I'm going to do the one that's easiest for me to do mentally as opposed to having to go get a calculator. So the one I can do mentally is 470 divided by 10 because it is a multiple or factors of 10. It makes life easier. So all I got to do is shift this decimal over once, and the unit rate would be 47, or 94 divided by 2 is 47. So if I divide any one of these, y divided by x, I will get 47. So do you need to divide all of the points in the table? No, you don't. Why not? Because I already know it's proportional. I'm not determining whether or not it's proportional. I'm determining the unit rate. And so since I'm determining the unit rate, I already know it's proportional. So that concludes the video. And I'm hoping you're able to see it this time. Thank you.